Dear participants gathering here in Kyoto, and dear online participants from all over the world. From now, we would like to start the international workshop on road disaster management using latest information technologies, world case studies on disaster management. This is the opening session, and my name is Uno Takumi, belonging to Hanshin Expressway Company Limited. Firstly, I would like to invite the president of Japan Road Association, the main organizer of this workshop, and ask him to make a welcome address. Please welcome, with big applause, Mr. KIKUKAWA Shigeru.
Good morning, everyone. I'm Shigeru Kikukawa, Chairman of the Japan Road Association. Please allow me to speak in Japanese. I'm pleased to welcome you to the International Workshop on Road Disaster Management using the latest information technology, which is a hybrid session of face-to-face and online sessions. On behalf of the organizers, I would like to welcome you. This workshop is co-sponsored by Japan Road Association and PIARC and supported by REAAA and is held with the support of highway companies and industry associations. I'd like to thank you for all of your support. Japan is known as a disaster-prone country. Every time we are hit by various disasters, such as earthquakes and torrential rains, we are keenly reminded of how roads are key social infrastructure linked to the lives of and property of the people, and transportation of goods, economic activities, and relief efforts during disaster are carried out using roads. We conduct research and surveys, provides results, and conducts international projects for the purpose of studying roads policies that are indispensable to people's lives, disseminating knowledge, and promoting the development of roads and transportation. Of these, the international projects that are the most closely related to today's workshop include cooperation with the International Road Organization, such as PIARC and REAAA, to promote the exchange of information among roads managers, engineers, and experts. The results obtained from these activities are intended not only for the international cooperation, but also to be returned to the members of the Road Association of Japan and other road-related parties in Japan. I myself have been deeply involved in these international projects, especially PIARC as Vice President until last year, so it's with deep emotion that we can hold this international workshop today. As I mentioned, due to COVID-19 situation, we are limiting the number of participants at the Kyoto venue and holding this workshop in a hybrid format. This format is becoming more common these days, and the Japan Road Association is also utilizing the internet to further enhance its activities, including lectures and seminars. Today, we have online participants, about 340 people, including 180 participants from overseas. And this workshop will be available on demand on later days. Disaster management for roads, the theme of today's workshop, is fundamental in formulating policies. However, the international situation, the socio-economic conditions around the world, and the environment surrounding road administration are undergoing dramatic changes, and disaster management deals not only with the strengthening of structures and networks, but also with the maintenance of supply chains, the use of information technology, and a wide range of other issues. In addition to the Technical Committee on Disaster Management, experts from the Technical Committee on Climate Change and on Bridges are also with us today. As the subtitle states, case studies of disaster management implemented in different countries. We'll have a technical session to talk about disaster management using information technologies, financial approaches to support various disaster management, and experts will have a panel discussion to discuss strategies for enhancing road resilience, and activities of the Disaster Management Technical Committee will be presented. We are also pleased to have Professor Emeritus Yuzo Onishi of Kyoto University as a keynote speaker. Dr. Onishi specializes in bedrock and geotechnical engineering, but he also has knowledge on various accidents and disasters, such as the Fukushima nuclear power plant accident groundwater countermeasures following the Great East Japan earthquake. Today he'll give a lecture titled Recent Road Infrastructure Maintenance Technologies Essential for Advanced Disaster Management. I hope that this workshop will contribute to the improvement and development of the road environment in Japan and abroad by sharing a knowledge of disaster management methods, their application to roads, and emergency situation management. I hope that the active exchange of opinions will make this workshop a meaningful one. Thank you very much.
させていただきます。どうかよろしくお願いいたします。
Thank you very much, Mr. Kikukawa. Next, I would like to invite Mr. Senoo Kei from PIARC, World Road Association. PIARC is the main organizer of this workshop as well, and he is a technical advisor. Mr. Senoo, could you come to the podium and make a welcome address?
Thank you, Mr. Uno, for kind introduction. My name is Kei SENOO from PIARC. On behalf of PIARC, I'm very honored to be here to convey our remarks from PIARC. Dear Mr. KIKUKAWA, President of Japan Road Association, Mr. Hashiba, Vice President of REAAA, Mr. Adachi, the chair of TC1.5, and also the director of Hanshin Expressway Company, and all supporting entities, and all guests, all speakers, all panelists. Thank you very much for coming to Kyoto workshop today. It is our pleasure to have this valuable workshop today. We hope we will have a great discussion and fruitful knowledge sharing today. Thank you very much. This is a small remarks from me. That is because we will have Patrick, Director General, will also give remarks at the end of the workshop in the closing session. So I'd like to have small presentation regarding introduction of PIARC. Oh, thank you very much. Okay, next slide, please. Thank you. First of all, I will explain what the PIARC is. PIARC is a new name of World Road Association, which is founded in 1909 as a non-profitable and non-political association. And there are 125 governmental members all over the world. Our goal is to exchange knowledge regarding policies and good practices for road-related topics. And our activities are technical committees, report publications, holding congresses, and workshops. Today's workshop is one of the most important activities of us. And our activities is based on the 4-year cycle. Current work cycle is 2020 to 2023 for 4 years. Next slide, please. This is about technical committees and task forces. For the current cycle, there are 4 strategic themes: road administration, mobility, safety and sustainability, and resilient infrastructure. Under the 4 themes, we have 17 technical committees and 6 task forces. TC1.5, disaster management, is one of them. And today's workshop is organized by TC1.5, disaster management. Yeah, thank you. Next slide, please. Our most important activities is World Road Congress. For the current cycle, we had 1 Congress in February this year. It was successfully finished. And also, we will have another Congress to be held in October next year. It will be held face-to-face in Prague, Czech Republic. And we published call for papers last month. And we are welcoming abstracts for papers. Next slide, please. This slide shows the PIARC publications, which are outputs of the technical committee's activities. One is the technical reports. We have 40 reports for 1 cycle for 4 years. For example, regarding the disaster management, we published 2 technical reports recently. Another one is online manual. Currently, we have 5 manuals on our PIARC website. And TC1.5 is kindly developing next one, number 6 manuals, risk management manual. It will be published soon. Next slide, please. Yeah, that is for my presentation. Thank you very much for kind attention. And also, we are very thankful to you all for kind support, kind understanding, and also kind contribution to our PIARC activities. Thank you all.
Thank you very much, Mr. Senoo. Dear participants, this workshop is also organized by REAAA, Regional Engineering Association of Asia and Australasia. In this opportunity, I would like to ask Mr. Hashiba Katsuji, the Vice President of REAAA and also the President of the Infrastructure Development Institute, Japan, to make a welcome address. Please welcome with big applause, Mr. Hashiba Katsuji.
My name is Hashiba, President of the Infrastructure Development Institute and Vice President of the Road Engineering Association of Asia and Australasia. On behalf of the REAAA, which is a co-organizer of this workshop, I would like to extend my greetings. I would like to extend a warm welcome to all those who are participating in today's seminar, both in person and online. I would also like to thank Mr. KIKUKAWA, President of the Japan Road Association, Mr. Patrick Malechak, Secretary General of the PIARC, Mr. Adachi, Chairman of PIARC TC1.5 Disaster Management, and Mr. SENOO of the PIARC Secretariat. And also Ms. Kieran Sharp, Chair of the REAAA Technical Committee, and Ms. Caroline Evans, Chair of the REAAA Resilience Committee, for their efforts. REAAA was established in 1973 to promote the development of road technology and exchange of information in the Asia-Pacific region, and currently has 1,400 members in 24 countries. In September last year, the 16th conference, a virtual meeting, was hosted by Philippines. At the conference, Mr. Kim from Korea was elected as the new president, and we entered a new period of activity for the next 4 years. REAAA and PIARC have been exchanging information on common issues in the areas of resilience, road pavement, and road safety. We believe that this seminar is a very valuable outcome of the collaboration between the two organizations. Today, Ms. Caroline Evans of the Victorian Government, Australia, will give a presentation on resilience initiatives for road transport, and Mr. Harry Vaza of the Ministry of Public Works and Housing, Indonesia, will participate in a panel discussion. We look forward to a lively exchange of ideas and opinions among the participants and hope that this seminar will prove to be a meaningful one. I also hope that the cooperation between PIARC and REAAA will continue to grow in many years and contribute to the road technology in the region. Thank you very much.
Thank you very much, Mr. Hashiba. Finally, Dr. Adachi Yukio, the chairperson of PIARC Technical Committee TC1.5 Disaster Management, and the director of the Engineering Department, Hanshin Expressway Company Limited, would like to make an opening remark of this workshop. Dr. Adachi, please.
Thank you. Good morning, everyone. My name is Yukio Adachi, the chair of the PIARC TC1.5 Disaster Management. On behalf of the PIARC TC1.5 committee, I would like to say a few words for the opening of this workshop. First of all, I would like to express my sincere appreciation to the Mr. Kikukawa, President of the Japan Road Association, Mr. Ishihara, Chair of the International Committee of the Japan Road Association, and Mr. Malechak, the Secretary General of the PIARC, and SENOO-san, the Technical Advisor of the PIARC, and Mr. Hashiba, Vice President of the REAAA for holding this workshop. And also express my sincere appreciation to the many organizations that support this workshop. One of the objectives of the technical committee, especially for us, is to investigate new trends in the disaster management and identify the common ideas and the good practices and disseminate them to the world through the workshops, seminars, congresses, and research reports. We held a kickoff meeting in Paris 2 years ago. Since then, our committee has continued our activities through the series of web meetings, and we published 3 research reports and held a webinar on disaster management in the COVID pandemic in collaboration with TRB, the Transportation Research Board of the United States. In recent years, the collaboration has been a key word in the PIARC activities. It is a fact that collaboration has been realized with increasing speed by using the web meeting tools. In this workshop, we could promote the collaboration with the REAAA, Regional Road Association, and the PIARC TC1.5, a climate change and the road network, resilience, and PIARC TC4.2, bridges. As a result of this, many technical presentations and case studies were made from 9 countries and regions, including Japan. We are confident that you will enjoy this workshop with an international flavor. We hope that this workshop will provide you with an opportunity to learn about the new approaches to the disaster management. Okay, thank you very much.
Thank you very much, Dr. Adachi. This is the end of the opening session. From now, we would like to have a 9-minute break, quick break, to change the moderator and set up the equipment for the session 1. Okay, please come back to this workspace by the starting time, 10 a.m. Okay, thank you very much.
Okay, ladies and gentlemen, I think we're good to go. My name is Piotr Hauka. I work for General Directorate for National Roads and Motorways Regional Division in Warsaw, Poland. I'm a head of Crisis Management and Security Division. And I'm pleased to be moderating technical session of this respectable workshop. I just need to remind you, we have 20 minutes for each presentation. I'll be gently reminding presenters in case of reaching the time limit. So, first, we have Mr. Ryushi KUBO, Director, Operation and Construction Department, Niigata Regional Head Office, East Nippon Expressway Company Limited, Japan, and his presentation titled Disaster Management for a Heavy Snowfall on Expressway, Record-Breaking Snowfall and Extensive Vehicle Stack on Kan-etsu Expressway. Please.
Good morning, ladies and gentlemen, and thank you very much for introduction. My name is Kubo, and I'm from Nexco East, and I'm going to present in Japanese. So this is the topic I'm going to cover today. A large-scale traffic stagnation due to intensive snowfall on Kan-etsu Expressway occurred in December 2020, and now we are working on the prevention of reoccurrence of such incident. And we are going to share some content about how we are working on the road disaster management in heavy snow. So this is the overview of the large-scale traffic landstill that happened in December, and you can see some of the pictures. It happened on 2 points on Kan-etsu Expressway, and about 2,100 vehicles were stuck in snow. And the snowfall back then was 113 centimeters in 24 hours, and this amount of snow was record-breaking in the observation history. And it took self-defense force as well as many volunteers and vehicles and buggy vehicles to resolve this incident, and it took 2 days to clear the stagnation. And this shows the location of vehicle stagnations. It happened about 180 kilometers from Tokyo. And you can see in the middle there is a Kan-etsu tunnel, which is 11 kilometers long. And as you can see, there are uphill from Niigata side to Tokyo inbound, as well as Tokyo to Niigata on outbound. On the inbound side, Shiozawa Ishiuchi Tunnel is the starting point, and 1,750 cars. And on the outbound, 350 cars were stuck. And next, I want to explain about the weather condition when we had the heavy snow. So that summer, La Nina phenomenon continued, and the water surface temperature in the ocean was relatively higher than usual, 2 to 3 degrees higher than average in winter. And the cold air mass flew in, and then that led to record-breaking snow. This shows detailed record of the snowfall. The blue line shows the snowfall forecast 24 hours before, and bar graph shows the hourly snowfall. The orange line shows the actual snowfall amount. So 113 centimeters in 24-hour window, which was earlier than the forecast and then heavier than the forecast as well. So after 24 hours of this heavy snow, traffic stagnation occurred. During that time, actually, we tried to have a road closure on the Kan-etsu Expressway, and then, however, the alternate routes such as National Highway 17 or E18 were already closed. And we tried to maintain Kan-etsu Expressway open as much as possible. And at the same time, it was very difficult to understand the real-time situation, and as a result, we end up having a large-scale stagnation of the traffic. So we analyzed, and there are multiple elements or factors. And this picture shows the initial response phase and snowfall stage, as well as disaster stage. So we did the analysis, but in case of this incident, the preparation stage had the highest number of issues. More specifically, 2 years before this stagnation happened, we had a warmer winter and then less snowfall. And in December, well, actually this was December, so it was the beginning of the snow season. And we are also facing the peak of the traffic and then large vehicles such as truck because of the seasonality. And according to the forecast back then, the amount of snow expected was something that we experienced in the past. So we have to admit that we had a lack of understanding and preparation for the worst case and sense of crisis. And it was difficult for us to understand what was going on site. And as an organization, we didn't have a capability to respond to something unexpected. And by the way, the location of the stagnation happened under Yuzawa office, but Yuzawa is one of the most heavily snowing areas in Japan. And they actually have one of the highest capabilities for snow removal in Japan. Nevertheless, even with their capabilities, they were overwhelmed because of the extension of stagnation, and all the vehicles were stuck. And they couldn't really exert the capabilities that they have for removing the snow. And this slide explains a similar incident happened in other expressways and highways. And the Ministry of Land and Transport actually made a change in their concept, because in the past, what they were thinking was to avoid closure as much as possible. But they defined that the highest priority should be given to save human life. And then we should avoid the massive traffic congestion. So that means we need to be more responsive to the disaster. So what we did at Nexco East is following the policy change of the government, we have been working on the prevention of reoccurrence. However, the disasters are becoming more extreme, and we have less and less people with hands-on experience. So there is a widening gap in disaster responsiveness, and we have to fill this gap. And it is necessary for us to make risk management as part of sustainable growth cycle of the organization. So now I want to share some of the example of what we are working on right now. Well, this is a traffic impact prediction. We have a threshold for abnormal snowfall, and this time Yuzawa interchange area is the one that had the heavy snow, and the threshold is 60 centimeters. This abnormal snowfall is the amount of snowfall that's expected to have 5 hours of closure, and in case of Yuzawa, which is 60 centimeters. However, we ended up having 113 centimeters of snow. And then we also prepare the organization with alert mode 2 in this case. And for the road users, we are trying to let them know in advance as much as possible. But at this moment, we are making judgment based on the amount of snow only. But in the future, we want to see the intensity of snow by hour, and also using the advanced promotion and snow removal capabilities. So we want to use other variables and combine them so that we can predict the risk of road closure quantitatively. And this shows 3 types of closures to avoid stagnation. The first one is called planned road closure or planned IC interchange closure. Well, basically, we announce the date and time of the closure. And the second one is the preventive road closure. There are 2 patterns in case the snowfall is overwhelming the removal capabilities. So this is a road closure after snow fell. And the last one is sudden or unplanned closure. For example, accident on the stuck vehicle can cause closure of this type. So in any case, we need to reduce the traffic amount according to the amount of snow to reduce the risk. And this is a type of traffic control we are enforcing right now. This one shows planned interchange closure. So interchange usually have a very complex structure. It's very hard to remove the snow, and they have a higher chance of accidents. So by closing the interchange, we can control the amount of traffic on the access road. The second type of closure is a preventive road closure, and there is A and B, but this is pattern B. So in this pattern, when there's an accident, basically we try to minimize the section of closure as small as possible, but that also made a concentration of traffic on the remaining lanes. And then we encourage detours now by implementing road closure in the wider area. And this slide shows how we can understand the on-site conditions among the stakeholders and using online system. We have CCTV and highway patrol teams with wearable cameras, and they capture the real-time video footage and share that video with the traffic police and our related organizations and agencies. And I will talk about this later, but this one helped us respond to the heavy snowfall that we had in the last season. Next. So in case and after a large-scale stagnation occurs, there are 4 stages of passenger rescue operation. Within 3 hours, 12 hours, 24 hours, and 24 hours or more, we distribute food or provide a place to rest. I mean, these are the part of the operation to rescue them. But after 24 hours, there is a serious risk on the health status of the passengers. So in this case, basically, we transfer them to the designated evacuation center outside of the road. And this picture was taken last November. And this is the joint operation training to rescue passengers. So once you have a traffic stagnation like this, we set up site coordination center on site in the local government. And then this works as a central place for the operations. So in this case, this bus rescued the passenger and transfer them to a safer place. So in order to go to this site, in some cases we need a small rotary vehicles or buggy fleet to go between the lanes. This one, well, as a result of these initiatives, and then I want to show you the results of what we experienced. Well, last season we had the heaviest amount of snow in the last 5 years. Here we have the amount of snow on the vertical line, and we have the hours of closure on the horizontal line. In 2020, we had a large stagnation, so we have an outlier here. But if you look at 2019, 2018, and 2021, the time of closure increased more than the increase of amount of snow, because we were able to take an early action and prevented the situation to get worse. However, if you think about the future, one of our challenges is how we can shorten the hours of closure. And there is actually the cost against snow responses increased by 20% on the regular years. And this is the result of planned IC closures. We had one planned closure last season on Kan-etsu Expressway and Horinochi and Yamato Smart interchange were closed. And we put the priority on the snow removal on main line. And as a result, the neighboring interchanges and the amount of traffic around there went down by 5 to 10%. And this was covered by many media, and the road users understood that this is a symbolic event of potential heavy snow. And this shows that a large, vehicle stagnation that occurred last year, which is 11 cases, 11 incidents, and all of them were cleared within 3 hours. The maximum number of vehicles was 460. And this shows on-site operations that we conducted last season. We used a variety of devices and cameras in the disaster prevention room. This is the wearable camera, and this is the CCTV, and this is the joint patrol with the police. And this one, we also learned that we find one-axis empty trailer are very vulnerable to snow. And using social network and then deliver information, Twitter, Line, and then we have a higher number of access actually peak when there is heavy snow. And before I close, I want to talk about what we're going to do in the future. Well, there is no room for us to tolerate more risk against large-scale stagnations. Therefore, we have to maintain the risk at a certain level, and then we need to increase our responsiveness. But in order to do that, we need the snow removal capabilities, but we also need the self-control by the road users as well as the traffic control. So these are the three elements that need to be integrated. And in order to optimize or maximize these three elements, we must supplement our experiences with digital technologies so that we can reduce the dependency on individuals and we can create an organization that can sustain its capability even with the turnover of people. And what we are working on right now is what's called Winter Road Management Niigata DX. There are 7 themes, and one of the themes is talent development and training. And then we have timeline, dashboard, and operation board, risk communication, and snow route decision support model, and archives. So these are the main themes that we are working on, and the red one already shows the work we have already done, and the one written in black is the one that we are going to work in the future. And we want to increase the risk communication with the road users, especially the distributing company, and then we want to establish the snow route decision support model with companies and universities. Well, so far I explained about what we have done in our office. But in Japan, we have a very complex and complicated operation, and this may be unique to Japan. So why we have to go through this type of complicated operations? And I think there are 3 reasons. One is the character of Japanese people, because they tend to think of the optimal answer or the overall optimization, and I think that's the first reason. A second, if you look at the highways and expressway in Japan, there is a road operator and there's another authority, which is the traffic controller, and those 2 authorities need to discuss and have a consent all the time. And thirdly, there is a lack of consistent support and understanding by media and the society. And at this moment, we still have room for improvement for the risk communication about heavy snow. So those are the 3 potential reasons leading to very complex operations. And we talked about the road management DX, but we want to take these into account and work on the digital transformation. So some forecast that we will have La Nina phenomenon 3 years in a row this year, which is the first time in observation history, and it's hard to tell what's going to happen in weather. But learning from the experience, we will continue to work on the optimization. Thank you very much. That was my presentation.
Mr. Ryushi KUBO, thank you very much. Now we'll have Dr. Yasumasa SOGA, Deputy Manager, Engineering Promotion Office, Hanshin Expressway Company Limited, Japan, and his presentation titled Disaster Management of Hanshin Expressway with Seismic Simulation.
Hello everyone. I am Soga from Hanshin Expressway. Thank you very much for providing me with this kind of opportunity. As was introduced, I am going to talk about the disaster management of Hanshin Expressway with digital twin technology. This is an initiative we are at the moment introducing, and it is still ongoing, but I would like to talk about the progress so far. So this is the agenda items that I'm going to touch upon today. As an introduction, I would like to introduce Hanshin Expressway. In 1964, the Hanshin Expressway has started its operation, so it's been over 60 years. And we have been collecting various data during the operation of the road, the daily inspections, and the road surface conditions. Such data has been collected. We also retain the data from the time of construction. So by accumulating such data within the cyber space, we have built a digital twin. Basically, that is the digital model of Hanshin Expressway, and by using this model, we analyze the condition using the accumulated data in order to optimally manage the road condition. So that's the intention of this initiative. It's called HISIMS, standing for Hanshin Expressway Infrastructure Cyber Management System. So the cyberspace and physical space are fused together in order to achieve the optimal management of the road. We are still in the process of making the model. On the left, you can see the actual pictures of the expressway. On the right-hand side, you can see the model's images. The red portion are basically the models of a Hanshin Expressway. So very complicated structures and also road bridges are expressed in the model. When the big disaster hit, the expressways and roads need to serve as an important lifeline. So before the disaster, we have to anticipate and predict what could happen and prepare ourselves. So we are working on the preparedness. So in terms of the length of the road, Hanshin Express has got 250 kilometers, and we have already built, or we are building the model covering the entire 250 kilometers of the expressway. Using this model, we run the simulation of earthquake. So the broad 250 kilometers of network is covered, and we are running the simulation of seismic response. And by doing this, we can predict and assess the damage degree of each portion of the expressway. So on the bottom you can see the image. On the north of the Osaka, looks like the damage degree seems to be low. However, in the south, it is closer to the Kansai Airport, International Airport, and therefore the importance of this highway is high. So we have to have a better preparation. So basically, we are running a simulation like this. So first, I would like to give you more details about the simulation we run. Basically, there are 3 steps in this simulation of earthquake. Step number 1. This is the deep ground response analysis. You can see the right circle on the right bottom. This is the epicenter of the earthquake. So in the deeper ground, what kind of a motion is transmitted, is simulated, and after that we run a step 2 analysis, which is the shallow ground response analysis, and we analyze how the earthquake or seismic motion is propagated, and after that we go on to step 3 in order to analyze structural response. So basically we want to run this cycle of step 1 through 3 at one go. As to step 1, this is still the work in progress, but the statistically Green's function method is used, and we measure and analyze the strain of the ground. In the step 2, this is the analysis of shallow ground response. So basically we used an application called the USA in order to measure and analyze large strain. This is basically 1D sequential nonlinear dynamic analysis. Step 3, it is the model on structural response analysis. Again, this is nonlinear dynamic analysis. We used a software called the SCENE-FEM or SCENE-FEM. On the left, you can see schematic from the superstructure. You can see bearings, pier foundation, and ground motion. So each part of the structure is modeled. Using these models, we simulated the 1995 Kobe earthquake. I would like to now show you the moving image of that simulation. The red lines are showing the network of Hanshin Expressways. And in the contour schematic, you can see the velocity of the propagation of the seismic activity. So this is the coastal expressways, and you can see the bridge, and closer to you is the road number 3 in Kobe. So from the ground to the structures, the seismic activities propagation is simulated on this software. This is still the work in progress, so the result of the analysis is not as accurate as we want it to be, but we anyway did a bit of analysis. On the right, this is a picture of the 1995 Hanshin earthquake, and this is the a picture of the collapse of built structures. The result of the investigation of the damage is summarized on the left. On the vertical line, we see the degree of damage. The red AS is the severest damage, and pink is the second severest, and the degree of the severity of the damage is expressed vertically, and the red is concentrated here. And this is basically the location of these built structures, and on the bottom, the result of the simulation is plotted. So the area around the built structures, the reproduction in the model is quite accurate. On the other hand, the other parts than built, there has been some discrepancy between the reality and the simulation. So in reality, the degree damage was A, however, it was not captured in the simulation. So we have to enhance the accuracy. Of course, we cannot accomplish 100% accuracy, but we have to analyze why there is still a discrepancy between the model analysis and the actual damage. So if we are able to do this kind of simulation using the software, then we can also anticipate and predict the damage of the future earthquake, and we can prepare ourselves. So we are now assuming 5 types of earthquake. So Hanshin Expressway is located in Kansai, so Uemachi Fault and Takatsuki Fault are the faults of concerns, and Nankai Trough earthquake and the Kobe earthquake, which took place in 1995, are the earthquakes of our concerns. And so we run simulation of these 5 types of earthquakes and see how the Hanshin Expressway structures will be affected by the earthquakes. So today I would like to show you some result of the analysis focusing on Nankai Trough earthquake. So this is similar to the previous example. This is a prediction of Nankai Trough earthquake. The velocity of the propagation is again expressed here. So in the center you can see Hanshin Expressway. The white line is the Hanshin Expressway. So this is the acceleration and seismic activities and motions. Velocity is expressed here, and in the future I also would like to analyze the structure's response to these motions. So how are we going to put these in the practical use? With the earthquakes that we are assuming, we simulated the degree of the damages. So the accuracy of the model is not yet that high, so the damage may not be as much as this. However, this is basically showing the trend of the magnitude of the damage. So Uemachi Fault, Arima Takatsuki Fault, and Nankai Trough earthquakes could cause a step on the Hanshin Expressways, and this simulation is trying to identify the potential location of such steps. Again, this is the result of the analysis from Nankai Trough earthquakes. So if there's going to be a step on that road, these are the potential locations. AS is the highest risk. So we can investigate furthermore. This is just a simulation, so this analysis might not be correct. However, this gives us an idea where we should prioritize in terms of doing some refortification or reinforcement of the expressways. So if with the assumption of the steps caused by the earthquakes, maybe we can also design the disaster prevention drills. When we develop the scenario of the disaster prevention drill, we can base that on the simulation results. And with that assumption, based on the model analysis, we can come up with a realistic disaster prevention drills. This year in April, we actually came up with a scenario based on the result of the analysis, and with the assumption that the expressways was staggered with the due to the earthquakes. The response plan was made according to that assumption. So this is quite a challenging initiative. Now, conclusion. The Hanshin Expressway has established the cyber infrastructure management system, and we are analyzing various data, and we also run various simulations in order to optimally manage the structures. We cannot make the very accurate simulation overnight, but we would like to move forward steadfastly so that we can verify the accuracy of the model. this time around, I particularly focused on the damage from earthquakes. However, there are other disasters such as the wind damage and also the water damage, and also the simulation of the traffic affected by the disaster can be run. This year, we have already experienced relatively large earthquakes in Japan, and Kansai experienced massive earthquake disaster in 1995. So in order to prevent the repetition of such a big damage, we want to do everything to prepare ourselves. And that's why we are doing studies. Thank you very much. That's all.
Dr. Yasumasa Soga, thank you very much. Now we will have Mr. Marcelo MEDINA, Head Department of Maintenance, Ministry of Public Works, Roads Directorate, Chile, and his presentation titled Road Emergencies in Chile and Information Management. I believe Mr. MEDINA will be online, right?
Hello, everyone. Thank you very much.
Please go on, Marcelo.
Hello. Is somebody... I have to change my screen.
Yes, go on. We're all right.
Okay.
Okay. We can see your presentation.
Thank you very much. All right. Well, I'm Marcelo MEDINA. I'm the PIARC TC1.5 technical executive, Spanish speaking. Well, at the road administration here for the Ministry of Public Works. I'm an engineer. I'm the chief of the road maintenance by Works. I'm also surrogate of the road maintenance department. We are involved in this, all the things that we see maintenance by housework, network, contracts, additional contracts, tunnels maintenance. So we're involved in this area. Well, Chile is at the edge of the South America. It's a continent here, and the ocean. So we're in the east. We have a range Los Santos here. We live at the ring of fire. We have a lot of disasters. All right. Our revenue is around 5,000, 86,000 kilometers. This is an official network. The kilometers not official. So we talk about around 1,000 kilometers. Chile is a country. We have the driest desert in the world. It's part in the north of Chile. We have a countryside, volcanoes, Pacific ice. Also, we have Easter Island. It's our Caribbean. But we also have disasters. This one was
sorry, Marcelo. Your internet connection is very not good, so please turn off your camera.
All right.
So please say.
It's okay, right?
It's okay.
Thank you. All right, we have a lot of disasters. This is an alluvium very close to Santiago, capital of Chile. Of this mudflow, and this is the look of this mudflow. We also have a lot of forest fire, very close to some populated islands. Earthquakes. We have the worst earthquake in the world. We are the number one amphibian earthquakes. But the worst things are tsunamis is the worst. So the whole, we have 5,000 kilometers of the coast. So any earthquake, almost seven grades, there will be we have as a we have a lot of machinery, around 2,000 units, heavy machinery, a lot of motor brakes, bulldozers, rollers, all those machineries that we use for the maintenance are the same for disasters. We're located in the whole country. We have 16 regions, 9 provinces. We have 1,450 agents on site. That's heavy machinery to struck by the workers, supervisors. These people are in charge of maintenance, but also they deal with disasters. We also have a contract around the country. So this is the tool that we have to face any disaster on the road network. We also have an organization, a national directorate, regional directorate, 16 regional directorates, and 15 provincial offices. So the people, this 450 agents are located here at the provinces. So when emergency occurs, have this along the whole country, all the risk. So we can deal with this kind of disasters, of course, in our country. They say Chile is hell. 2 years ago, we had the worst fire in Chile. This is in the north, because in summertime, we have a lot of rain over the mountain, and the height of mountains are very high, talking about 5,000 meters high above sea level. So you have a lot of there, and it's not snow, it's rain. So they flow down with a lot of speed. So we have this kind of disasters very, very bad. This is something that happens summer at the north of the country. But we have also like a mountain range, Los Angeles mountain. Have a lot of snow. So from the center to the south, we have a lot of snow. We have this kind of problems sometimes. And this is something is coming with the climate change. We have been having this white spot. It was not quite rare in my country, but now are very common. during winter. So we have been facing water that is now are incoming into the cities over there. So we have a different kind of problem. Well, but it can also have this mountain range. So this is something that's not new. It's always very beautiful to see, but not that beautiful to face. When we talk about disasters, our goal is recovery, activity, and transitability as soon as possible. This is our goal in the administration when we face these crises. So we have to recover the transitability or the connectivity. But you can see this what happened in my country. We have a kind of disaster. We also have forest fire. That's not a really road administration. At least fire is affecting some road infrastructure, but we have to do something with it. We deal with it when this fire was in the area. This is the work that the administration does, kind of disasters. But we are in this digitalization phase. So we are using digital information. And this is only since 2015, when we were in this closed source information. We call it CMO. It's an emergency information system, Ministry of Public Affairs. But it's exclusive for agents of Ministry of Public Affairs. So since 2015, we have digital information of these disasters.
So Marcelo, sorry. So even now your internet connection is not so good. So we will share your slide. So please turn off your slide, and we will share your slide. And you will start presentation. Okay.
Okay. Perfect.
Please restart.
Okay. Next one. So we have since 2015 information, digital information about disasters. Next one, please. So in this we have a lot of disasters. We started in 2015 fire close to Valparaiso, its own country, it's a main city, fifth region. Next one, please. We also have an earthquake in the middle of our country with the tsunami. Next one, please. This alluvium is cutting this city in the desert north of the country in the same year. Next one, please. That was in this alluvium. And also we have that volcano at start. That was only in 2015. So we have all digitalized for this event. Next one, please. Next one, please. So we have a detailed information in a system allowed to see every agent of the Ministry of Public Works. Next one, please. Another one. And allows us to produce these emergency maps. And this map is shared by internet site for the road users. Next one, please. Next one. And the detail at the web page. The detail info. Next one. This emergencies work with the next one, please. Another one. It's we world-class system enterprise access asset management. So it's use maintenance management and also next one for the machinery maintenance. Next one for the purchase. Next one storage money. Another one. But the information management. So the system, it's linked with all those information. Next one, please. And if I make this kind of with the information, this is the road map. Next one. This task to use this device visual engineering was a project that we're dealing with for 10 years. So we finished now. At last, we have a database so we can do this and link all the information to the road on the map. Next one, please. Another one. Okay. Another one, please. This information, as I said, with information, the road maintenance. Next one, please. With the work orders, the contract payment, and machinery use, everything. So we have the whole resource we're using is the registry record. Next one, please. Next one. But we have advantages with it. We have agent training program, permanent. We have coordination meeting, permanent every year. We have a permanent emergency records. Next one. Another one. But we also have a disadvantage. Another one. Next one. Another one. Information is key for the ministry agents have access to general users only the information that's published on the map. We use technical concepts to this information. The risk level evaluation is this is a big technicians bring, but the general users, they don't know which is the level of evaluation. So it's something that's not the same, technical thing used to say another thing. Very different. But the main thing here is that we have slow collecting data that is close. It's very technical. It's very detailed. Very record. Next one, please. So what's the main problem? Next one. Another one. We have the information. Next one, please. We have an historical. So we can do now some analysis with this information. Next one, please. Another one. But it's an able for access to another one. I know those users are too many and not trained. Another one. And we have also authorities asking us what's going on with the road during emergency. Another one. So thinking about another one, please. Too many and next one. Another one. So thought about it. Well, we need to think explanation and relate to the official rule. Next one. So we can use an open source for faster information also. Another one. So we can add the citizens. Next one, please. Improving this, adding the citizens for the detection of road emergency. Next one, please. Thank you. So we provide them a simple challenge. Next one, please. So, and also we have information, instant management, another one. And we can integrate information with the current system. But we're not generating a parallel system. So we have to integrate all this. Next one. So we have this we are developing tool for the citizens, something very easy to facilitate this support, and also develop a different or an open source information. Next one, please. So citizen interface be very easy with the link with the internal manager. Next one. Next one. So when we have all collaborative input from the community, but that don't require an injected response, so we don't have to respond to every emergency record that the community sends us. So we can use that information. Next one, please. We show the emergency. We show the emergency. So the status of the emergency record must be updated permanently. Next one, please. The open source good just for intelligence and for the general public. It's just for money. Next one, please. And the information coming from the open source can be related to the information. So we combine this. Next one, please. Will require different management. Open source problems information is quick information, but it's not accurate. But closed source, technical and very logical. Next one, please. Another one. So, in the extension we're having with this project. Next one. So we have this report, source, and we also. Next one. We are going to this open source with the closed source. Another one. And we are going to provide also to the agents a new interface, easier interface to report the emergencies on their roadmap. And what next one? And provide this information. Next one, please. To a map. Next one, please. And this map we will share with other organizations. Next one, please. Put here, one name it is the office where we share now by a map, detailed information. And next one. Thank you very much for your time. This is the status of the emergency management of our country in South America. Thank you very much.
Okay, thank you, Marcelo, Mr. Marcelo Medina. Thank you very much. Okay, and now I would like to welcome Mr. Chin-Fa Chen, Deputy Chief Engineer, Directorate General of Highways, Ministry of Transportation and Communications, Taiwan, and his presentation titled Using the Latest Information Technologies to Establish the Road Early Warning System and Response in Taiwan.
Okay, please wait.
Okay, we can see your presentation.
Okay, thanks for introduction. Audio and the video is okay. Okay. Hello everyone, this is Chen Jin-Fa speaking at Taiwan site. I'm working in the Department of Transportation. Road maintenance and disaster prevention is my duty. I'm glad to have the opportunity to share Taiwan experience about prevention disaster by using IT. This is my outline. I will take Suhua Highway as a case study. And then I will give you some background information about the road. Suhua Highway at Taiwan is in here. Have very beautiful scenery. The road one side is ocean and another side is rock here, similar to California Highway 1 with steep cliff. In the past, the road width is 3 meters, but now they then become 9 meters, maybe for business or I don't know. In rainy days, sometimes often occur landslide. If unlucky, may be hit by rock fall. This is the most serious and famous case at the road in 2010. Please follow this area. Post the Typhoon Meiji, 26 people were killed caused by disaster in here. It's very painful for us. We want to improve it urgently. We established a disaster prevention system at 10 years ago and start using information technology 3 years ago. After implementing the early warning mechanism, no more enduring events. The result is zero causality for 10 years. And then, let me give you our strategy about reducing risk. Risk is determined by hazard, vulnerability, and exposure. Now, I will show you the different implementation in normal time how to reduce vulnerability. And in the rainy day, how to manage exposure to avoid disaster. Let me show you our responding protocol during disaster. We have 1, 2, 3. 3 levels of responding protocol are set up: early warning, and action. All stages of responding are judged based on the preset rainfall index. When the hazard condition reach action level, the traffic control would be close and monitor closely. And then I will show you about how to organize information technology in normal time and in an event. The briefing shows the type of information technology currently applied in Taiwan's highway. Green color text is this research application, have Internet of Things, AI, cloud storage, data knowledge, drone, and the 5G. Blue color text is other traffic management case. Let me show you the transmission diagram to explain application principle. According to our findings, there are 5 transmission paths. Please follow this legend. The drone located by GPS. The transmits the image to the cloud storage device through 5G. After image recognition processing in the engine room, it is immediately sent to the control center. Please refer to advice. And show you our SOP. We have 6 steps. Step 1, using drone to detect disaster on the slope above road. And step 2, grading by quality analysis. And step 3, grading by quantity analysis, means advanced grading. And step 4, detailed inspection by drone. In this step, we will create 3D point cloud map to find out rockfall area and make improve project. But rockfall area map cannot be improved by engineering. We'll install rockfall warning system. First, I will show you the result of the digital elevation model by using overlapping multi-periods in order to find out disaster area. The color appears to represent change in elevation. Indicates that the slope has collapsed or accumulation. And next slide shows the method of detailed inspection by drone. By using image processing technology to create 3D point cloud maps, could be easily find out rockfall. After find out rockfall area in here, will be analyzed rockfall rolling track and design the position of the protective net in here. When the rockfall area that cannot be improved by engineering, it will be installed rockfall warning system like this slide. Warning pass by to avoid disaster. The slide shows the system work efficiently actual case in Taiwan, 2019. According to our findings, Roadside warning sign had an emergency notification for passerby to avoid disaster. The above briefing notes are for routine maintenance to reduce vulnerability. And then I will show you a diagram of risk management for the raining day, like this. How to measure exposure to avoid disaster. The threshold is accumulated rainfall by using big data analysis. Let's give you big data analysis application. First, we get road collapse probability model like this graphic. Through calculation formula by select 10 years road disaster record. I will show you the practical application case. The graphic shows the system auto calculate the real-time lapse probability based on the rainfall data returned by on-site rain gauge. And then let me show the actual application at the Suhua Highway. Next page slides show the transmission diagram of various intelligent disaster prevention systems. Please refer to advice. We integrate 4 systems into one intelligent disaster prevention system. System 1, we call it early warning system by cell broadcasting. And system 2, we call it roadside risk information display system. And 3, we call it the rockfall warning system. System 4, trapped vehicle auto detection and rescue notification system. As the screen shows, when the intelligent disaster prevention system detect severe rainfall, various protective devices will be started up, like system 1, 2, 3, 4 will be started up. I will show you the effects verification test. According to our finding, when real-time risk transmission reduced 68%, like this. 68% of traffic volume before road closure. Screen shows the system 4. Affect vehicle auto detection and the rescue notification system by using auto vehicle identification and drone. Is it summarized? Summarize 1, by using information technology, such as drone, data technology, and Internet of Things to integrate into the early warning system. For transmitting real-time emergency road messaging to passerby, avoid possible disaster in time. The implementation effect has been verified to be excellent. And 2, in Taiwan Highway, the early warning mechanism has been in operation for more than 10 years. And by using information technology application has been online for more than 5 years. No one was injured by falling rock during this period. My briefing is over. Thank you for your attention, and then I will happy to answer any questions in Twitter. Thank you.
Mr. Chin Fa Chen, thank you very much. Now we can have a discussion. We have quite some time. Please, if you have any questions, let me know. Anyone? Here you are. Can we have microphone? Oh, please say who you direct your question to.
Is it okay?
Yes, please go. Yeah.
Okay, I have a question for Marcelo. Good evening, Marcelo. This is Kei SENOO speaking. Can you hear me?
Yeah, very good.
It's my pleasure to see you on the wave.
Thank you very much.
Thank you too. Yeah. Thank you for your very informative presentation. It is unfortunate the internet connection was not so good. So please allow me to ask you a general question. My question is, what is the most effective mean or way to convey information to road users during or after a major disaster event? I would very much appreciate it if you could share your experience with us.
Well, we're still working on it. We are now developing the open source of information for the road users. And we are, the first thing we are sharing with the user the unique road database that we produce. So any information that they send us will be linked to the specific road. That specific road, we got it on a map with the GIS system. So we are able to locate any position that is road users send close or very near to this detailed information that we have on the system. So we are able to locate all this information, and we can have a class of information very close to our technical record. And users are able to see the photographs, descriptions, but always we need to standardize some information that we can use and we can link with our information. You need something to do the link. That is what we're working on. And we are developing the application to do it, and are already using this location of any point that the user sent. We can locate it with our road network. Yeah. That is what we're doing now.
Okay. Thank you. Thank you, Marcelo, very much.
All right.
I think I can refer to that. It's a very important thing, open source cooperation with our clients. I think that's the future. So thank you, sir.
Thank you, Marcelo. Yeah.
Anyone? Please, don't be shy. Ask a question. That's the... Oh, Dr. Yukio, please. Oh, can we?
Can I speak Japanese?
Of course.
Kubo-san, thank you very much.
Thank you. I was very impressed with your work. And if you think about the disaster prevention, in your case is a very good example of a very sophisticated case. But when we talk about these cases to people from overseas, sometimes it's very difficult to communicate how great it is. So this is not so much as a question, but rather a comment. basically you try to reduce the amount of traffic first and then work on the snow removal and basically improve the capacity, so you have the approach on both ends. And in order to reduce the traffic amount, I mean, that's something that's very difficult to explain. So maybe you can add some wording and add some explanation, and I think that will make it easier to understand for the international audience as well. Thank you very much for your comment and the question. Well, as you said, if you think about the heavy snowfall, what's important is how we can reduce the traffic, and then we can also decentralize the traffic as well, so that we can avoid concentration of traffic. And what we can do today, for example, Japan Railway have a planned closure of operation, and I think that's also accepted by the public. So we have to do our activities on our end so that we can get the support from the public to have the planned closure in heavy snow. So in that case, I understand that we need to work more on the promotional activities, but thank you very much for pointing that out.
Thank you very much. Anyone else? Oh, here we have a gentleman back there.
So Peter.
My name is Soga from Hanshin Expressway. I have a question to Kubo-san.
I was a little nervous about my presentation, so maybe I missed this part when you talked about this, but basically, in order to understand the situation on site in real time, and then you kind of coordinate it as a team with the local municipality and people on site. But in order to capture the information on site, rather than depending on people, for example, using camera or other type of maybe autonomous vehicle, I mean, do you do any technologies there? Or do you plan to use any technologies in the future? Well, thank you for the question. This is Kubo from Nexco East. So what we want to do in the future is basically you want to use camera all the way to monitor and manage. But in Niigata, we have 430 kilometers of expressway, and then we have about 230 locations where we have camera. So on average, we have camera every 2 kilometers. So what we do on 2 kilometers at this moment, basically we depend on staff. The staff go there on site, use the web camera, and then send a live broadcast to the stakeholders. But in the future, in the time when we have connected car, we want to have a semi-automation with camera. I know Hanshin Expressway already have many cameras, but we hope in rural areas we want to equip with cameras as well. But thank you very much once again.
Okay, very nice. Anyone else, please? We still have some time for discussion. Oh, please, of course.
PIARC のセノーと申します。阪神高速の曽我さん。
This is Seno from PIARC. I have a question to Mr. Soga from Hanshin Expressway Company. I think you are running simulation only for the bridges, but are you planning to do the simulation for other part of the expressways? The background of this question is because I have been involved in the post-disaster restoration at the time of the Tohoku earthquake. So not only the beams, basically on the backside of the road, there can be some loosening of the bolts or something, and therefore that can also cause the step on the surface of the expressway. So are you planning to run the simulation on that as well? Thank you for your question. This is Soga, as you have said. We are at the moment doing the making the model only on the part of the bridge beams, and about 80% of the Hanshin Expressways are elevated roads, and that's why we are focusing on that part. And there's also, the model for bridge abutment and also bridge beam, but on the road and tunnels, we haven't yet developed the softwares or models, but in order to do the disaster management, we need to also cover that part of the expressways in order to have more sophisticated preparation for the disaster management. So we are planning to do that. Thank you.
Okay. Some more questions? Anyone?
Peter, I have received a question from web participants. Okay?
Okay.
So the presentation about Kubo-san, to Kubo-san, the question is how many times did you do the operation per year? The question.
So this is a question to Mr. Kubo. How many times do you conduct operation that you presented? Well, we usually have about 10 times when we have warning for heavy snow in Niigata, in our area. So once we have this warning, the operation level has to be on the alert mode too. So that's one of the highest level, and then it happens about 10 times a year. Thank you.
Anyone have a question? Dr. Yukio, please.
So I have a question to the Chen-san. They are from Taiwan. Can you hear me, Chen-san?
Yeah, I hear.
Okay, thank you for the nice presentation about the early warning system in Taiwan. And now you implement that system into your real road network. My question is that the very last slide of your presentation, you showed us the some use of the drones monitoring devices in the real road system. So how do you use such devices when you are disaster management? So preparedness, response phase, and recovery phase. How do you use it?
反应就 response 的阶段去侦测那些，就是刚刚简报里说的那些在这预防。
OK，接下来我请我的口译人员来帮我翻译。
Next, I will translate for Mr. Chen for answering the question. Thank you.
我们的无人机升空是靠 GPS locate 定位。
Our drone launches is located by the use of GPS.
借由5G 传递影像到影像处理器去辨识。
We will use 5G communication to process and transport the images captured by the drone.
影像处理器会帮我们找出车辆的车牌号码。
The image processor will help us to identify the license plates of vehicles.
那我们公路管理单位对于车牌号码，我们有管理资料。
We have a database for the license plates, which is administered by the government side.
我们会即刻透过管理资料通知 相关的公司或个人以及消防单位。
We will find the related information from the database, and then we will contact the related corporations or persons.
同样的，我们的公路目前公路客运已经装有 GPS 坐标，我们可以在电脑上面监控。
And furthermore, we have the coordinates of GPS of our all highways, so we can locate the vehicle and the location of highways precisely.
这些管理资料只是针对救援使用，不做其他用途。
This information will be only for the disaster mitigation and prevention, and not for the use for open or other use or usage, other purposes.
Okay, that's all. Thank you.
That's our answer. Thank you very much.
Thank you very much, Chen-san.
Thank you very much. Do we have, oh, please, Mr. Jungkook.
Yes, I have a question to Mr. Kubo. Actually, you said after 24 hours, you rescue them out. That the people get stuck in the snow, you rescue them out to the designated place. So how do you deal with their vehicle? You just towing them out too, or you just leave them there and get the people back to the vehicle later? How do you deal with your vehicles?
Thank you very much for the question, and this is Kubo. Well, in case of December 2020, the historic snowfall and stagnation, basically all the passengers stayed in the vehicle, so we didn't have to take care of the vehicle. However, they had to stay in car for 2 days. So it had an impact both mentally and physically. So for the future operation, basically we try to rescue people outside of the road after 24 hours. That's the operation we have in place. So what's going to happen to the vehicles, to your question? Basically, vehicles will stay there on the road. But meanwhile, we are going to work on the removal of the snow and make sure the road condition is ready for the vehicle can move. So we will bring the passenger or driver back to the vehicle and they will move the vehicle. So it's going to be a time-consuming operation, but that's what we assume for now.
That's a very client-orientated process. Very nice, very nice. Anyone else, please? We still have time for, I think, another question. We better use the time. Oh, here we have gentleman in the middle.
Next,
Nicola speaking. I have a question to Kubo-san.
About how to deal with the vehicle. So in Japan, when a disaster strikes, I mean, not just limited to snow, but basically, if there is a request from the local government, I mean, we have the authority to remove the vehicle. And does this apply in case of snow as well? Okay, it does. But in your operation, you just explained, if there is a request, there is a possibility that you will move the vehicle. Is that the correct understanding? Thank you for the question. So the operation I just explained is in case of traffic stagnation with a large number of vehicles stuck on the road. But if it's like dozens of vehicles, as Mikura-san said, basically applying the law of disaster prevention, and the road operator like us will basically force move the vehicles. We can do that too. But depending on the number of vehicles left on the road, I think we have to be flexible how we deal with it. Thank you.
I think that will be time to finish our technical session. Very interesting presentation. Thank you for questions, also very interesting. We will have at least 3 minutes to change moderators and prepare for the next part. Thank you very much.
Good morning. My name is Chris Engelbrecht. Remove my mask here so you can hear me. My name is Chris Engelbrecht. I'm with the Missouri Department of Transportation in the United States. I'm the assistant to the Chief Safety and Operations Officer for the Safety and Emergency Management Unit within our department. And I will be your moderator for today's session. So this session will be focused on our work group updates. So our first presentation will be by Mr. Jan Gruber. He is our Working Group 1 leader for PIARC's TC1.5 disaster management. He is the ministerial counselor for the Ministry of Transport in the Czech Republic. So please give a warm welcome to Mr. Gruber.
Mouse. Just change the pages by mouse. Yeah, okay. Thank you. Thank you very much, Chris, for my introduction. Let me add something that I work at the security department. I'm involved not only this TC group, but of course in all phases, management, crisis planning, crisis management, emergency, civil emergency planning, defense planning, and as well critical infrastructure protection. So, how was said, how mentioned, Working Group 1 is in TC 1.5 disaster management, and we are focused on information and communication in disaster management. This first topic is use of big data and social networks for disaster management. Next. Okay. First of all, a little bit definitions. Very briefly, big data. What is big data? Everybody knows, but refers to large, diverse sets of information. It encompasses the volume of information. The big data are a variety or the scope of the data points. Social networks, if you will define this, use internet-based social media. Everybody knows that. Social networking can have a social purposes and business purposes, or both. You know, Facebook, Twitter, everybody have this, Instagram, WhatsApp, and so on. What is open sources? If you talk about information from open sources, we talk about information available for public consumption. Closed sources of information, on the contrary, are available only to a limited group of individuals, and it's not available for general public. To our work, we developed an international survey, which was made up of 15 questions, falling under 7 main themes, which follows types of frequency collection, types of data and frequency collection, validation techniques, ensuring accuracy data, how to analyze data, so using technology, softwares, and etc. Who and how the information is disseminated. Of course, the benefits for road administration and road users. We touch as well, actually, topics COVID-19 and applications, big data and social networks. And we touch as well relevant information, so case studies, we collect projects or obstacles you face during implementation of the specific technologies. We received 46 responses. The survey from 22 countries, how you can see from all over the world, Asia, Europe, America, and Oceania. We received as well 9 case studies as examples of the use of information management related to roads and emergencies. Case studies are from China, Poland, Japan, Czech Republic, Chile, and South Korea. Analysis of the case studies will be delivered in the final report of the Working Group 1. So now it's in the stage of analysis, evaluation, and moderate a little bit for template or case studies for next using. Some important preliminary comments. Use of big data and social networks. What is very positive, over two-thirds of respondents replied positively to collect and analyze during any stage of disaster or management emergency life cycle. Almost 70%. Yeah. Almost equal split between big data, social networks, and majority of data collected was related to disaster traffic information, infrastructure, and weather data, mainly to response files, almost 70%. Collection, big data, and social networks collected are most information is related to response files of disaster. There is mixture between manual and automatic methods. And the vast majority of organizations, this is negative information for us, the vast majority of organizations don't have appropriate means of analyzing the information, almost 70% again. What is important for open and closed sources information? For open is accuracy, most significant accuracy. Most severe concern is followed in data interpretation with other databases. This is valid for closed sources. What is positive is that everybody knows and feel benefits from big data and using social networks information, 70%, and this is advantage for us for crisis planning and so on. Very briefly, conclusions about technical aspects. We are a lot of applications and softwares which collecting data information for any of the stage of emergency life cycle. We use closed sources information with greater accuracy in data, and but for restricted to group of people who must be permanently trained and coordinated. On the other hand, open sources information has greater scope by involving users, but the accuracy of the data is less. So according to the results of the survey, it is one of the major concerns for organizations. And what is important, combination of closed and open information sources, because it increases the efficiency, effectiveness of emergency information management. Recommendations to the decision makers. Big data, social networks are important tools. Provide opportunities to improve the supervision of road infrastructure at all stages of emergency cycle. Therefore, it's essential for stakeholders to continue explore opportunities for further users. Due to the fact that there is a wide range of interests, it's suggested that coordinated leadership could enhance the broader coordination of effort. Next conclusions is recommendation to the international organizations. Each organization has its own information needs, information sources, and the ability to analyze the data and the technology. In this sense, the results obtained by each organization will be similar, but often not compatible. So it would be essential to establish standard parameters related to emergencies and their stages. And what is, again, very important is sharing case studies and discussing lessons learned in these matters is an efficient and fruitful practice. This is the end of my presentation. You can see final product, which is the use of big data or social networks for disaster management. Yeah, it's able to upload on websites for PIARC. Thank you.
All right, thank you, Mr. Gruber. Our next presentation will be for Working Group 2, Ms. Saki YOTSUI. She's the Working Group 2 co-leader. She's an assistant professor with the Department of Civil and Environmental Engineering at Ritsumeikan University in Japan. So welcome.
Thank you so much. Good morning, good afternoon, everyone. My name is Saki YOTSUI from Ritsumeikan University. So actually, Working Group 2 leaders are Mr. Paolo and Ms. Sara from Italy. But because of the time differences, unfortunately, they couldn't join this session. So on behalf of Working Group 2, I'm going to give you an update on the current situation of Working Group 2. So we are working on the financial aspect of disaster management under the TC1.5 disaster management. So first, what has been completed and what needs to be completed. So we need to achieve and conduct briefing notes and full report. It means technical reports. So one of the briefing notes have already been completed, and it is published on the PIARC website in English and French and Spanish. So in the 3 languages. Then here is the table of the contents. So Working Group 2 considered the formulation of an international survey to be the easiest way to gain information in the international area. So survey was distributed during the early 2021 in English, Spanish, and French, and it distributed to the wide variety of the organization, public road administration or private road organizations, and emergency management section, and university or research institute. So Working Group 2 obtained 39 responses from 31 organizations in 17 countries. So I will explain conclusion a little bit. The road networks are exposed to natural elements and disaster that may cause the severe damage to these assets. So it is therefore important to be financially prepared and have disaster management processes in place, including various sources of parallel fundings. So international survey results suggest the need for every road organization to invest in the development of new warning or monitoring systems of widespread phenomena such as flood, heavy rain, and heavy snow, and to promote more sustainable mobilities. And it will be also practically important to systematically quantify the financial risk associated with the different disaster scenarios, and to make use of the cost-benefit analysis for all investment plans. Now let's focus on the full report. We are going to use case studies which we have already received from our TC1.5 members. During the April 2021 parallel meetings, we thought the full report should be based on the collection of case studies, But last year, we had the 3 case studies from one in Romania, 2 in Italy. For example, in Romania, they provide us the risk financing management of high floods on Donesti Bridge. But unfortunately, there are not sufficient number of the case studies, so we asked the TC1.5 members to see if there is any case studies that could be offered to us. Then we received total 11 case studies from 9 countries. As a result, the case study covers a wide range of disasters. For example, earthquake, flood, tsunami, and wildfire, and the country itself. So this is the concept of full report. The next full report will include the case studies collected, as I mentioned so far, so exactly what we received them. The chapters are structured based on the disaster management cycle at the same of the briefing notes, namely the phases preparation, mitigation, response, and recovery. And another chapter will be used to comment and integrate the case studies with using literature review, practical experiments you have heard about, and ongoing project on your organization. Then we are planning to give suggestions to the low medium income countries and road administrations, PIARC, and from the financial aspect of disaster management point of view. So this is from the working group to updates. So thank you for your attention.
Thank you, Saki. And our final activity report will be for Working Group 3. So Mr. Constantin ZBARNEA, he is the head of technical department for the Regional Division of Roads and Bridges in Romania. Welcome.
So I think I will start to share my screen. Is okay, or you will run my presentation from your computer?
Go ahead and share your screen.
Okay, thank you.
Constantin, on behalf of you.
Just a minute.
Oh.
Just a minute.
Okay.
So, my name is Constantin ZBARNEA. I'm the working group leader for the working group number 3. Our term of reference for working group 3 is to update and to develop the disaster management manual. First, develop as a book, and to get together all the knowledge and all the experience that we get from the previous cycles of PIARC. And we almost did that. For the first part, we just realized the disaster management manual as a book. We developed this book, and we also drew and designed the cover for the book, even it was not our...
Sorry, Constantin. So your slide is very small. So on behalf of you, I will share your slide. Okay.
Okay. So I'll start sharing my screen. I'll start sharing it. Okay.
Ah, yeah. Okay.
Okay. So this is the cover that we talk about. we designed this this cover and we drew it. So this will be our manual as a book. The most important thing that we will finalize the manual, and the next step will be to develop the web version for the manual, which is much, the next slide, please, which is much easier okay, this is the website. The website is now in the stage of the backstage, because we are still uploading some chapter in this web version. The manual is practically divided in 5 sections. Each section is made of a group of 10, which are the activities that support disaster management. So this horizontal red bar will appear at the top of each page and show the section. Next slide, please. For the first section, for the management, in this section, Hyogo and Sendai framework, resilience and disaster management cycles are presented, and also the basic technologies from all fields that contribute to the advancement and efficiency of disaster management. This part contains this basic technologies, which are developed by a company from outside PIARC, but the Japanese company. Next slide, please. The next important section of the manual is regarding mitigation. This section refers to the activity that prevent emergency or disaster and reduce the likelihood of disaster occurring, or relieves the impact of unavoidable disaster on roads. Because mitigation is a combination of structural and non-structural measures. In the recent years, community of disaster management has focused on strengthening social infrastructure. So we call this social infrastructure social capital or community resilience. And this refers to the ability of the community of neighborhood or to work together to cope with the disaster and to resume the daily life. Next slide, please. Next section is regarding preparedness. This section refers to the activity that enhance management skills in order to reduce the impact of disastrous event on the road by responding appropriately and recovering as quickly as possible. We are talking here about BCP, business continuity planning, hazard identification, early warning, training and exercises that are very important key factors in preparedness activity. Next slide, please. Response, this section refers to the activities that take preparedness into action. So response involves disaster information management, coordination and cooperation with national or local governments, evacuation, and ITS. Each one is developed in this section, also with case studies and references. Next slide, please. For the recovery, this section refers to activities to repair the road damage from any emergency or disaster caused by unwanted event, and to deliver the road function to its pre-disaster state, or maybe to a more resilient state. In this chapter, we present the recovery from common disasters and from uncommon disaster. We also get together the experience in uncommon disaster, which is practically new, and we develop our own definition for uncommon disasters. Uncommon disasters refers to large-scale disaster and combined disasters. Next slide, please. I will give here some example inside the manual just to show us that we are not in the stage of the main chapters only. So this is an example of preparedness measures. The next slide, please. And this slide shows us the many case studies that we present in the manual. We took case studies from all over the world, and these are case studies, for example, for the uncommon disaster recovery. We also have a lot of tools in this web page. We have search tools. If you type something in the tools section, you can click on the magnify glass. You will see all the location where this term exists in the manual, and everything will be listed automatically. You just have to click on the chosen title to be automatically redirected toward to this page.
Can you give final comments, Constantine?
Okay. So next slide, please. This is our working group member list. We're a small group, but we work very close together during a lot of web meetings in the last 2.5 years. Next slide, please.
All right. Thank you very much, Constantine.
Thank you. I'm sorry I couldn't be there together with you.
All right. It looks like we are at a break for lunch. So the return time looks like we'll start again at 1300. So enjoy lunch.